Hello guys, welcome to today's lecture. Today we are going to be talking about probabilities. We're going to be reviewing some topics in probabilities that we're going to see later in this course. Probability is defined as the chance or likelihood of an event happening in the long run. It can be expressed as a decimal, fraction, or percentage. I'll have two main types of probabilities: experimental and theoretical probability. Experimental probabilities are those probability values we obtain by actually doing the experiment. For instance, if I roll a die 6 times, I might get the number 2 4 times. So the probability of getting a 2 is 4 out of 6 in that particular instance. And this reduces to 2 out of 3. But the theoretical probability is the probability we will get based on what we already know about the event. For instance, the theoretical probability of getting a 2 is 1 out of 6 because I know that I have only one 2 out of 6 possibilities. Okay? Now there's what we call law of large numbers, and this is the probability, this is just telling us that as we repeat the experiment, the experimental probability approaches the theoretical probability. Okay, so they get closer to each other. So in this particular example, if we continue to experiment, the probability of getting a 2 will get closer to 1 out of 6. Okay, so let's look at the probabilities of the properties of probability. It's if P of x represents probability of an event x, then we know that probability cannot be less than 0 and cannot be more than 1. So 0 to 1, that's the values of our probability. Cannot be more than 1, cannot be less than 0. In other words, it can be negative and it can be 1 point or any number more than 1. If the probability of an event is 0, then it means that the event cannot happen. For instance, the probability that December 25 is not Christmas is 0 because we know it's a sure thing. The probability can also be 1 if we are sure that the event is going to happen. If the probability that December 25 this year is going to be Christmas Day is 1 because we know that that is what happens for sure. So let's define some terms. We'll talk about sample space. Sample space is the set of all possible outcomes. For instance, when I roll a die, I know that I have 6 numbers that can show up, 1 through 6. So if I have this set that contains all possible outcomes, then that's considered a sample space. So the probability of getting a sample space is always equal to 1. Also, if I toss a coin, I have two options, head or tail. So this is the sample space. So it's a set that contains all the possible outcomes. Then the event is actually what I am interested in. If my interest is getting an odd number, then the odd number becomes my event. If I'm interested in getting a head from a toss, then that becomes the event. So let's look at some basic definitions. The probability of an event P of x is number of required outcomes divided by the total possible outcomes. Okay. Now let's say for instance we have in a classroom I have 5 boys and 10 girls. So to find the probability of getting a boy, it should be 5 out of the total, which is 15. 5 over 15, which is going to be 1/3. So this is a classical definition of probability, number of required outcomes divided by the total possible outcomes. So if I have, 2 red balls and 3 blue balls, the probability of picking a red ball is 2 out of 5. We have 2 red balls and a total of 5. Okay? So let's have more examples here. The probability of picking a boy in a class of 20 students with 5 boys is going to be 5 because we have 5 boys divided by the total 20, which is the number we have in the class. The probability, of course, this is going to reduce to 1/4. 5 divided 20 is 1/4. Okay, make sure you always reduce your fractions. The probability of getting a 2 when a die is rolled is 1 out of 6 because we have only 1, 2 and we have 6 numbers. So 1 out of 6. The probability of having an even number is when a die is rolled is 1 out of 2. Of course, the correct or the initial answer we get is 3 out of 6 because we have 3 even numbers, 2, 4, 6 out of 6. So 3 out of 6, which reduces to 1 over 2. And the final example, the probability of getting at least a 3 when a die is rolled is 2 out of 3. At least means that 3 is the smallest number. So we have 3, 4, 5, 6. Okay, 4 numbers out of 6. So that reduces to 2 out of 3. Okay, so now we have another way we can represent a probability. We use tree diagram. Suppose a woman will have 2 children. Find the probability that both are girls. Well, if they have equal probabilities, then the probability of getting a boy will be the same as probability of getting a girl. Okay? But in this case, we are assuming unequal probabilities that the probability of getting a boy is 0.4 and probability of getting a girl is 0.6. So this represents the first child. The first child is either boy or girl. Okay, and the probability of getting a boy is 0.4. The probability of getting a girl is 0.6. That's the first child. Then this is the second child. Now this says that if the first child is a boy, the woman can still have a boy or a girl for the second child. If the first child is a girl, then we can have a boy or girl. Okay, now and again, the probability of getting a boy after a boy is 0.4. Probability of getting a girl after a boy is 0.6. Probability of getting a boy after a girl is 0.4 and probability of getting a girl after a girl is 0.6. So now you can see BB right here. The probability of getting boy is going to be the product of the two probabilities. 0.4 times 0.4, that's 0.16. That's what we have here. Okay, and then to get a boy first and a girl second should be 0.4 times 0.6. That's B girl, BG, boy first, girl second. So that's 0.24. The probability of getting a girl and then a boy is going to be 0.6 times 0.4. That's GB. That's 0.24. And then the probability of getting girls, first girl, second girl, is 0.6 times 0.6, which is 0.36. Okay, so you can see that when you add these together, you get 1.0. So the probability that both are girls will be GG. First is girl, second is girl. That's 0.36. We're going to stop right here. We're going to continue next time. I hope you had a good time listening. Thank you. Bye bye.